Lesson number 5, daily summary. In this lesson, we define the slope of a line, and we see several ways to calculate and use slope. A portion of road A climbs steadily for 120 feet over a horizontal distance of 4,250 feet. Let's take a look at this picture. So here's the road itself right there. That's the road. And it says that it climbs 120 feet, that's this part, and then over a horizontal distance of 4,250 feet. Note that this diagram is wildly out of scale. This 120 should be a lot smaller relative to the 4,250, but that's okay. A portion of road B climbs steadily for 95 feet over a horizontal distance of 2,875 feet. Let's draw the same kind of triangle here. Again, that's the road, the diagonal, and it says it climbs 95 over a horizontal of 2,875. And that's road B. And we want to know which road is steeper. Which road is steeper? So on the one hand, I look at this 120 and I say, oh, look, that one is climbing more than this one. So therefore, this road is steeper than this one. But that's oversimplifying things, because although it's true, the road A is rising more, it takes longer horizontally to get that bigger rise, right? It takes 4,250 feet to get its rise, whereas this road does only 2,875 feet. So the problem is that these horizontal distances are different from each other. If I could somehow get those horizontal distances to be the same, then I could use my intuition and I could just compare the vertical distances, and whichever vertical distance is bigger would represent the steeper road. But that's only if I can get the horizontal distances to be the same. So we will calculate the steepness. I'm defining the steepness of a line by finding the ratio of the vertical change to the horizontal change. Again, I'm thinking of trying to focus on getting the the horizontal numbers to be the same. And so we're going to put that horizontal change in the denominator of a fraction. So 120, this is road A's steepness number. 120 is the vertical, divided by 4,250 is the horizontal. We get a steepness number of 0.028. Let's do the same thing for B. It's the vertical change on top and the horizontal change on the bottom. So vertical for B, 95. Horizontal for B, 2,875. And let's type that into the calculator. So we do 95 divided by 2,875. We get our steepness number of about 0.033, around that. Okay, so what do these two steepness numbers mean, and can I use the two numbers that I now have to figure out which road is steeper? All right, let's force both of these steepness numbers to look like a fraction. So I'll divide both of them by 1. And I will remind you that when we made this steepness fraction, we put the vertical change on the top and the horizontal change on the bottom. So this is a vertical change on the top and a horizontal on the bottom. And the same thing is true over here. That's a vertical over a horizontal. And what can you say about these horizontal numbers, just the denominators of my two fractions? Well, now the horizontal numbers are both 1. They're the same as each other, which means now I'm free to focus on the vertical changes. I can compare them to each other. Now it's apples to apples. Before it was kind of apples to oranges, looking at the 120 compared to the 95. But now that the horizontal changes are the same as each other, they're both 1, I can compare these two vertical changes, and the bigger number represents the steeper slope. That 0.033 represents more of a vertical change per 1 horizontal foot than the 0.028 represents a vertical change per 1 horizontal foot. So here's a complete sentence with both of the steepness numbers included. Since the steepness of B, which is that 0.033 number, is bigger than the steepness of A, which was 0.028, road B is steeper. To measure the steepness or slope of a non-vertical line, we use the ratio that measures the vertical change, which is the y-coordinate, to the horizontal change, which is the x-coordinate. So it's the same idea. We're just defining this word slope. You've probably seen it in previous math classes before, but it's really just a measure of steepness, and it is always the vertical change over the horizontal change. Shorthand notation that defines slope uses the symbol delta, that's a capital D in the Greek alphabet, which often represents a change in math and science. And we can use the letter M to stand for slope. And there are a lot of different ways to think about slope. They're given in that big equation there, but let's just actually see if we can use the let's see if we can calculate slope in one particular example. In a previous class, this was in a demo, I think. Sorry, not in a demo, in an activity problem. We graphed the equation y equals negative 200x plus 800, which showed the altitude y of a hot air balloon in feet, x minutes after releasing air from the balloon. And there's the graph of that equation, y equals minus 200x plus 800. So let's see if we can calculate the slope of that line. And to calculate the slope, we need 2 points. So in this case, we're going to pick the points 0, 800, and 3, 200. Let's plot those. 0, 800, and 3, 200 right there. And in order to calculate the slope, what we're going to do is this crazy looking formula right here. It's subtract the y values over subtract the x values. Said another way, change in the y coordinate over the change in the x coordinate. So let's do that in this case. I'm going to do the change in the y coordinates first. 800 minus 200. By the way, m, remember, is our letter for slope. 800 minus 200 over, and then we do the change in the x coordinates. 0 minus 3. 600 on top, negative 3 on the bottom. Negative 200 is our answer. That is the slope. So don't get lost in all the subscripts up here. Y2 and Y1 are just saying the two different y values, the two y coordinates, and you subtract them, and that always goes on top. And then x2 minus x1 is the two x's subtracted on the bottom. Okay, so then it says in part C, now you pick any 2 points on the line, but don't pick the points that we just picked here, and let's calculate the slope for 2 different points. You can pick any 2 you want. For the purposes of this video, I'm going to pick, what am I going to pick? Let's do this one here, and we'll do this one way down here. So carefully writing the coordinates. That's 4, 0, and what is this? 1, 600. And let's go ahead and calculate the slope using the 2 orange points. So always up on top, we subtract the y's. So I'm going to do 600 minus 0, that's subtracting the 2 y's, over, and subtract the x's. 1 minus, actually kind of regret one of my choices here. Let's make a different choice, gang. Sorry about that. Let's choose this one right here. 2, 400. There was nothing wrong with the points that we had picked before. The slope would have worked out just fine. But I've got a reason I want to pick a different point here. Okay, let's try it again. Subtract the x's, subtract the y's first. 400 minus 0 divided by 2 minus 4. So upstairs is 400. Downstairs is negative 2. And when we do that division, we get negative 200. Hey, what do you know? It's the same as the blue slope that we just calculated up above. And it turns out no matter what 2 points you pick on a line, you will always get the same exact slope. So that means you could pick any 2 points you want. So the slope of this line is negative 200. Okay, so we just did D. I got negative 200. It doesn't matter which points you pick. Okay, F. What does the slope mean in this situation? So in order to determine what the slope means, I need to have some units. So let's fill in some units here. Okay, let's look at the units for the blue points. 800 and 200 right up on top. 800 and 200 were measured on the vertical axis, which was feet. So 800 and 200 were both feet. 0 and 3 were measured on the horizontal axis, and that was time being measured in minutes. So this negative 200 is really negative 200 feet on top, minutes on the bottom. So something is changing at negative 200 feet over minutes. And I'm going to make one small change. Instead of saying over, I'm going to say the word per. Negative 200 feet per minute. I think making that one small change can really go a long way to writing a sentence interpreting what that slope means. Something is changing at negative 200 feet per minute. What is it? It's the altitude. The altitude of this balloon is changing by negative 200 feet per minute. And hopefully that feels reasonable. Like that's a good interpretation of what that negative 200 means. But even if you're in a totally unfamiliar context and you have no idea what the problem actually represents in real life, you can still write a sentence. Get the word per in there, and then I'll tell you that the thing that is changing at this, negative 200 feet per minute is always the output variable. Whatever variable is on the vertical axis, that is the thing that is changing by the slope, negative 200 feet per minute in this case. So the altitude is changing by negative 200 feet per minute. So here are 3 full credit sentences that interpret that slope. Good sentence. The balloon's altitude was changing at negative 200 feet per minute. Better sentence. The balloon's altitude was decreasing at 200 feet per minute. That decreasing takes care of the negative, right? This balloon was falling. And actually, that's the best sentence. The balloon was falling at 200 feet per minute. One thing you don't want to do is write decreasing at negative 200. That's no good. You say decreasing, don't write the negative. Okay, couple of common pitfalls to avoid when calculating slope. The slope is the change in y over the change in x, not the other way around. It is not x is on top and y is on the bottom. It is always y is on top and x is on the bottom. Really easy to get that upside down. And part B, you need to be consistent in the order that you subtract in the numerator and in the denominator. For the points here, these are the points that we had. We correctly calculated slope by subtracting in this order. We did 800 minus 200 on top here, and then 0 minus 3 on the bottom here. And we were consistent in the direction that those arrows went. But you cannot do, but was there something else you could do? You could have done 200 minus 800 on top and 3 minus 0 on top here. Notice that the arrows are going in the same direction. In this case, they're both going from right to left. But you cannot do 800 minus 200 over 3 minus 0. That is no good. The arrows are not pointing in the same direction. We did not subtract in a consistent order. If you do 800 minus 200 on the top and then 3 minus 0 on the bottom, that is wrong. You won't get the right slope. It'll be close, but it'll be wrong. You get 200. Isn't that the slope? No, slope is negative 200. So if you subtract in an inconsistent order, you will get the opposite sign, which is no good. So make sure you are subtracting in a consistent order when you calculate slope.